Okay, good morning to all of you. In our last class, we have been discussed about relativistic addition of velocities. In that last class, we have discussed that suppose this is a frame of reference that is the S. Another frame of reference is S dash, which is moving with the velocity is V with respect to S frame. And if a particle, suppose this one, is moving with a velocity u in S frame, then what will be measured from S dash frame that we have been discussed? And suppose the particle is moving in S dash frame with the velocity u dash, then what will be the measurement by this observer who is sitting in S frame that we have been discussed in our last class, and we found the six major equations. That is your suppose u is the velocity in your S frame, then it has three components ux, uy and uz. So then ux dash, uy dash, uz dash in S dash frame will be how much? This one. This is your equation number 1. Ux dash, uy dash will be this one. It is your equation number 2, and uz dash will be this one. That means if u is the velocity in S frame, then the frame of reference which is moving with the velocity v with respect to S frame, in that frame of reference, if the person is sitting here, then this person is going to be measure the velocity of this particle or component of velocity of this particle will be ux dash will be this much, uy dash will be this much, uz dash will be this much. That we have been discussed in our last class. Similarly, if a particle is moving with u dash in S dash frame, then what will be the velocity component in S frame, or the person who is sitting in S frame, what will be the components this person is going to be measure? Here these are the equations. That is your ux will be this much. That is your equation number 4. Ux dash plus v by 1 plus v by c square ux dash. Uy will be equal to uy dash 1 minus v square by c square root over by 1 plus v by c square ux dash. Uz equal to uz dash into 1 minus v square by c square root over by 1 plus v by c square ux dash. Equation number 4, 5 and 6. These six equations we found by using Lorentz transformation equations. So this much we have been discussed in our last class. Now we are going to use this concept and we are going to do some problems in this lecture. Okay. Now, by considering these six equations, which is belongs to relativistic addition of velocity 1, 2, 3, 4, 5, 6, we are going to do the first problem. I suggest first write this question, then you have to pause the video and write down the answer whatever I'm going to be discuss. So here using velocity transformation, so that the value of an angle is relative and changes in from one reference frame to another. That means uh, by using velocity transformation we have to show that the angle is different from one frame of reference to another frame of reference. So here I am going to draw the two frame of reference. That is your, this is your S frame which is at rest. This is your S frame. This is X, Y and Z. Okay. And S dash frame which is moving along positive X axis direction is this one. This is your S dash frame, Y dash, X dash and Z dash. This S dash frame is moving with velocity v with respect to S frame. Now consider a particle which is moving with a velocity u in s frame, making an angle theta. This is your u velocity. This is the particle, suppose, which is started from the origin o, and this is, we know that, is your o dash. Okay, and this particle, suppose, moving with velocity u, making an angle theta in your S frame. Okay, then what will be the angle measured by this observer who is sitting in S dash frame? Suppose this observer is sitting over here in S dash frame. What will be the angle? The angle will be same theta, or it will be changed. This is the theta. Okay, this is theta which is measured by this observer who is sitting in S frame. So here we can write that if this is the velocity of a particle u, and this is the angle with respect to x-axis, then this velocity has two components. This will be your ux component, and this is your ux component. This will be, this vertical will be uy component, right? So now ux will be how much? U cos theta. Uy will be equal to u sin theta. Okay, अतएव tan theta will be equal to uy by ux. Okay, hence theta will be equal to tan inverse uy by ux. That means this theta is measured by the observer who is sitting in S frame. Okay, now the person or the observer who is sitting in S dash frame, that person is going to measure what angle? Is this same or different? It will be different. How it will be different? Because theta is a function of velocity component uy and ux. So as this frame of reference, that is your s dash, is moving with a velocity v, then we have to consider here the so-called relativistic velocity addition. So how much in case of s dash? In the person who is sitting in s dash, what will be the angle? The angle will be theta equal to tan inverse. Here here I can write s dash means theta dash. Tan inverse is your uy dash by ux dash. Here uy dash is not equal to uy, ux dash not equal to ux. According to velocity addition, relativistic velocity addition, these are changed different value as compared with these two values. Uy is different than as compared with uy dash. Likewise, ux also different compared with ux dash. So now we have to consider the value of uxy dash and uz dash will be how much. Already we found that is uy dash is equal to this much and ux dash is this much. That we have to be substitute over here. Then how much it will be is equal to tan inverse uy dash. Uy dash is equal to this much. Uy 1 minus v square by c square root over by 1 minus v by c square ux. That we have to put. That is your uy 1 minus v square by c square root over divided by 1 minus v by c square into ux whole divided by ux dash. Ux dash is this much. This is your ux minus v by 1 minus v by c square ux, that we are going to be used over here. Ux minus v by 1 minus v by c square into ux. Close the bracket. These two are same, got cancel. Okay, now we found theta dash is equal to how much? Here uy into root over of 1 minus v square by c square divided by c. Uy 1 minus v square by c square divided by ux minus v. Ux minus v. This is tan inverse. This is tan inverse of this one. So here we found theta, which is measured by the observer who is sitting in S frame, is tan inverse only u y by ux. But here theta dash, which is measured by this observer who is sitting in S dash frame, for this particle, what will the angle? Angle will be this much. Tan inverse uy 1 root over of 1 minus v square by c square by ux minus v, which is not same with theta. So hence proved. Here in the question we have to show. The question was show that. So here theta dash is not equal to theta. Hence proved. Write down this question and its answer perfectly in your note, which will be useful for your exam. Okay, we have to go for the next question. Now come to the next question. Question is that first you write the question. Okay, a spaceship moves past Earth with velocity v. It sends out a pulse of light ahead of it. Find the speed of the light relative to an observer on the Earth. So what is the question? Here I drawn the figure, that is, this is your Earth reference, that is your S frame. The person is sitting here. Another frame, or that is a spaceship, moves past the Earth, means cross the Earth or past the Earth, moving with velocity how much? Moving with the velocity v. That means this S dash frame belongs to your spaceship. Okay, spaceship past the Earth or moving with velocity v with respect to Earth. Okay, now find the speed. Now it sends. Who sends? Spaceship sends. Here in the spaceship frame of reference, a light pulse is sends this side, this way, ahead of it. Ahead means along which direction that spaceship is moving. In the same direction, a light pulse. This is I written ligst. This is ligst. This is the light pulse is sends out ahead of it. So light pulse means what will the speed of the light? That is the c. That means this c velocity is measured by this person who is sitting in S dash frame. Okay, now question is that find the speed of the light relative to an observer on the Earth. So now the person who is sitting in S frame or Earth frame, what he is going to observe? The speed of the light is going to be decrease or increase or going to be change. That we have to find out. So this is one of the interesting question. Here we have to prove that it is not going to be changed. Previously we studied that light speed not to be changed with any frame of reference. From any frame of reference, wherever we have to measure, the speed of the light is always constant. That is your one of the postulate of special theorem, relativity. So here we can found. Now we are going to I am going to do the solution. At last I am going to found that this person also going to measure the speed of the light is also c. That means here the light pulse or the light particles velocity is c, which is measured by s dash frame. But according to velocity addition, we can expect that this person is going to be measured different velocity of light from this frame of reference, but it is not so. At last we are going to find that this person also, which is in earth frame, he is the person going to measure also the velocity of the light is c. Let's do it. So we know that ux equal to ux dash plus v by 1 plus v by c square ux dash. Here the velocity component only along only x axis, so I am going to consider this one only. Okay, so here ux dash is c. So velocity measured in s frame with respect to s dash frame is nothing but is your ux equal to ux dash plus v by 1 plus v by c square into ux dash. This is the equation. Okay, according to relativistic addition of velocity, ux equal to ux dash plus v by 1 plus v by c square ux dash. So here the light pulse is moving only along x axis, so only we have to consider x component only. Okay, now consider that implies, now consider this ux equal to u, and now consider that ux equal to u and ux dash equal to u dash. You can consider, may you not going to be considered in this way, direct you can write. Okay, ux has been considered as u. Ux dash will be u dash plus v by 1 plus v by c square u dash. Here u dash is nothing but equal to c. That means the velocity of the particle or the velocity of light in your s dash frame, that is velocity of particle or the so-called light in s dash frame. Okay, now we have to put the value. Here what we are going to get, see, that implies u dash equal to c plus v by 1 plus v by c square into c. How much we can get? C. The numerator is c plus v by here how much it will be, c square plus cv by c square is equal to, will be c square gone to numerator, c square into c plus v by, this is from this I can take common c, and we found c into c plus v. You got my point? From this I can take c common, means c plus v. So c plus v got cancelled, and at last we found c got cancelled, and we found that this value is nothing but c. Carefully you have to write in the note. So here we found the observer, this u means the velocity observed by this observer who is sitting in earth frame. Also how much we got? Also we got the same answer, that is P, which is well supports to the special theory of relativity. According to postulate of special theory of relativity, the speed of the light measured from any frame of reference is constant. The speed of the light measured from this frame of reference, that is your from S dash frame, is c, S frame also c. Okay, so write down this question and answer carefully in your note. Now consider another important question, that is your a rocket A travels to right and another rocket A NOTHER and another rocket B travels to the left with velocity 0.2 c and 0.1 c respectively relative to the earth. What is the velocity of the rocket A is going to be measured by the rocket B. So whatever written in this question that I am going to draw over here. So I suggest that first you write this question perfectly with the red pen. Then you have to write the answer in the note. Okay. So what is the question has been given? First we have to consider the earth frame of reference is S. S is the earth frame of reference. Whatever I drawn in green pen, that is your X, Y and Z. One spaceship, or we can say one rocket or spaceship, travels to the right. This S dash, suppose one of the frame of reference, or we can say that is the rocket A moving with velocity how much? 0.2 c towards the to the right. Okay, and B travels to the left with the velocity 0.1 c. Another frame of reference or another rocket B is travels towards the left with the velocity 0.1 c this side. Now the question is that what is the velocity of the rocket A measured by the rocket B? So if the person who is sitting in this is your S double dash frame, B is the rocket and S double dash frame, suppose if this person who is sitting in this S double dash frame, then this person is going to measure what will be the velocity of rocket A, or we can say frame of reference S dash. So here this is your another person who is sitting over here. So here earth frame of reference, the person is sitting here. So this person, for this person earth frame of reference, one spaceship or one rocket A is moving 0.2 c towards this side. Another rocket B is moving with velocity 0.1 c towards this side. This person is measuring. Okay, with respect to earth, S dash frame, or we can say rocket A moving towards this side with velocity 0.2 c. Another rocket B, or we can say another frame of reference S double dash, is moving with velocity 0.1 c towards this direction, opposite direction of this one S dash frame. Now the person who is sitting in S double dash, how much velocity this person is going to measure of this rocket. This rocket has the velocity 0.2 c with respect to earth. Now who is the person who is sitting in S double dash frame? For this person, what will the velocity of this rocket, that we are going to be find out. So before we have to do this question, first we want to just recall whatever we have been studied in our relativistic addition of velocity. These are the 6 equations. Here you can see this is U is the velocity of the particle with respect to S. With respect to S, this is the velocity of the particle. Now if this is the U, then what will be the velocity of this particle from this frame of reference? That is your U, that is your Ux dash. Okay, so Ux dash, Uy dash or Uz dash, the 3 components which is measured from S dash frame will be equal to Ux minus V by 1 minus V square by C square Ux. Okay, and here V is the velocity of this S dash frame, which is moving frame. Now here you just compare that This is your earth frame of reference. So here you can see that this is your earth frame of reference and this is your S dash frame. Now I am comparing this one with this. See here, whenever we have been discussed about relativistic velocity addition, one is earth frame, one is frame of reference S dash which is moving with velocity v, and another particle who is moving with velocity u in S frame. Now you can see that in this case, here this is the S frame, and with S frame, this S double dash is moving with velocity 0.1 c towards this side. That means we can say that if we are going to consider this S dash is equivalent to this S double dash is equivalent to S dash, and this S dash frame it belongs to the particle u. Then we can found the velocity of this u with respect to S dash, or here we can say velocity of A with respect to B. Again I am explaining, you just carefully watch. This is your S frame, this is your particle which is moving with velocity v, another frame of reference S dash which is moving with velocity v, and from this S dash frame we have to calculate what will be the velocity of this particle. So here this S dash frame is considered as the particle, okay, which is moving with velocity 0.2 c with respect to earth, okay, that is your this one. Now another frame of reference which is spaceship rocket B which is moving with velocity 0.1 c towards this side with respect to earth. Now from this frame of reference B, what will be the velocity of S dash or this particle that we are going to be measure, okay. So now we are going to use this velocity of addition formula, that is your ux dash, okay. So here we have been considered that the so-called here S dash frame or rocket A is considered as the particle, okay. Consider, you just write perfectly, consider as particle moving with velocity equal to how much? 0.2 c. That is nothing but is your v, is your this is your u, this is your u, like the particle which is moving with u with respect to S. Here this rocket A is considered as particle with moving with velocity 0.2 c with respect to S, okay. Now we have to consider this frame of reference. So S double dash, that is frame of reference or rocket B is moving with velocity equal to v equal to minus 0.1 c. Here minus 0.1 c because this velocity is opposite to this particle, that means towards this earth observer. If away from the earth observer, we can say that is your plus 0.1 c, or we can say this velocity or this motion towards the negative x-axis direction. Only for that we consider minus 0.1 c. Now here we found v is minus 0.1 c is equivalent to velocity of S dash frame and velocity of the particle, that is your u, we found as 0.2 c. Now we have to find out the velocity from this frame of reference, that is your, here this is s double dash, but here this is s dash. So now from this s double dash frame of reference, what will the velocity of s dash or velocity of the particle? That is considered as u dash. U dash equal to how much? Your u minus v, because this formula, this, as the motion is only along x axis, we have been considered only x component. First we have to write the x component form. Ux dash equal to ux minus v by 1 minus v by c square ux square by 1 minus v by c square into ux. So let's consider ux dash equal to u dash. Now here we have been considered that ux dash equal to u dash and ux equal to u. Then this will be modified as u dash equal to how much? U minus v by 1 minus v by c square into u. All the values has been given here. U is nothing but is your 0.2 c. This is your 0.2 c minus v is minus of 0.1 c. So it will be plus 0.1 c divided by 1. Here v we have been considered v is your minus 0.1 c. So here if we have to put, it will be plus. So it will be plus 0.1 c divided by c square into u is nothing but is your 0.2 into c. So the numerator value is 0.3 c divided by here c square into c square. This is got cancelled. 0.1 into 0.2 value is 0.02. That means 1 plus 0.02. So by simplified we can get, after simplification we can get 0.294 c. That means the person who is sitting in rocket B or in S dash frame, he is the person going to observe the velocity of this frame of reference or the rocket B or whatever we consider particle as a particle. The velocity is going to be measured by this observer of this frame of reference or this rocket will be 0.294 c. 0.294 c. Okay, write down this question perfectly in your note. So for this class up to this much. Next class we are going to be discuss about relativistic mass and momentum. Okay, thank you so much for watching this video. Thank you.